Let's have a look at simultaneous equations. Now, we have seen simultaneous equations before, but I think it's really cool that we have things like this, which at its face value just seem like a cool little puzzle, right? But these methods really are an introduction to how we can solve these simultaneous equations, right? Simultaneous, we've got two things happening at the same time. Often that means we have two equations. You might even see ones now that have more than that, right? But here's the rule of thumb. Here's the rule of thumb. So, for every unknown, we need a separate equation to solve for it. So every unknown that we have, we need that number of equations. And so we have that here, right? We have two unknowns, x and y, two equations. Two unknowns, two equations. And we've learned two methods to deal with them. What was one of the methods that we learned to solve simultaneous? Yeah, substitution. That's one of the ways. Substitution. Now, why substitution is good is it's very easily identifiable, right? Substitution is great when you have things like this. If I have y equals to something and y equals to something else, I know that these two things must be equal. It doesn't just work in these situations. Substitutions will always work. But kind of like when we're thinking about tools, right? We want to use the right tool for the job. So maybe substitution will always work, but the issue is if you're using it on a different type of equation, there may or may not be lots of algebra that you have to do, okay? So depending on the type of question, substitution might not be the best method. And that's why we have our other method, which is elimination, right? Elimination works on the premise that we're saying, okay, I have two equations and they actually interact with each other. And I can treat them like I can add or subtract whole equations. Just how you would add or subtract three-digit numbers, we can do the same with these simultaneous equations. But now with elimination, we're trying to remove a variable. Okay, so that's what elimination is. We're trying to remove a variable. I guess with the advantages, it can be quicker. You have to choose what operation you have to do there, right? You have to either add or subtract them in order to eliminate the variable. You need to choose an operation. And sometimes, if you want to use elimination, then it might not work straight up. You might have to even create a new equation, okay? So we have really two options there. We either use substitution, which will always work. It's a surefire way of solving our simultaneous, but it might not always be the best way, right? Or we use elimination. And I think the ability to choose between both of them is what will make you more confident in these. But like I said, a situation like this, if I have y equals to something and y equals to something else, I can immediately straight off and say, oh, I know I can use substitution here. It's very easy to replace, right? I could say, and again, labeling my equations, we'll sub 1 into 2. And I'm saying, okay, 2x minus 3, that's the same as y, so I can equate them like so. And remember, the goal of these is that, just like all equations, we're trying to find a variable here, right? So I'll do some rearrangement, maybe subtract x from both sides, add 3 to both sides, and I'll get something like this, which just will simplify to x equals to 4. Okay. That's my first variable. What do I do with this now? Yes?
Sub it in.
We'll sub it in, right? I've found one of the answers, but that's not the full picture. And again, I've seen students just leave it like this. I said, oh, yeah, there you go, x equals to 4. But remember, simultaneous equations, they often have more than one variable, right? So I'll say, I'll take this, I'll say, let x equal to 4 in, I don't know, which equation looks easy to you? Maybe, yeah, I think 2 looks easier, right? Because it's simple addition. So in equation 2, and I think it's really important to be communicating to whoever's doing this what you're actually doing. So maybe you won't write this out every time, but if I'm reading something and the working isn't so coherent, I'm not really sure what you're doing, I love seeing stuff like this because I know what's actually happening. What steps are you taking? What's your thought process, right? So I'm letting x equal to 4 here, and so y will equal to 5. So my answers are x equals to 4 and y equals to 5. Okay. not too bad, right? We've seen stuff like this before. We can also use elimination. And like I said, what does elimination aim to do? It eliminates one of the variables so that we only have an equation with one of them. And here I can do that exactly. I can choose to either add or subtract these equations. Have a look at this one. What operation might I want to do here? Yeah, I do. Yeah, let's try elimination. Okay, so let's see what happens if I add. Now remember, I'm thinking about it like 3-digit addition, subtracting. And I should really say I'm adding equation 1 and 2 instead of just drawing out like that. So we're doing 1 plus 2 here. And what am I going to end up with? Well, if I take this out, I've got 8x here, plus y, plus negative y. That's just going to go away. I'll get left with 0y, and that's 16. Okay. So if I take equation 1, add equation 2, I'll end up with 8x equals to 16. And divide both sides by 8, x is equal to 2. And then like before, I can substitute it back in. Both of these look, I know, pretty similar. Let's take maybe that one. Okay, so sub x equals to 2 into 1. And again, I've got 6 times 2 is 12, plus y is equal to 15. And then we'll just rearrange to solve that, right? Subtract 12 from both sides, so y is 3. 2 answers. How do I know they're right? Yeah, can you solve it back and check for me? Does it work? Good. Any questions about that? Now, someone told me a interesting mnemonic to remember what action to actually take in terms of elimination, right? They told me that if you have, like in this case, unlike signs, you add, and if you have the same signs, you subtract. And the way they memorized it was US of A and triple S. Okay? So maybe that might help you out. This is only assuming that we have the same coefficients here, right? So these have a coefficient of 1 and -1. These two have a coefficient of 2, right? So I'm thinking, how do I get rid of one of the variables here? Well, they have the same signs here. So if I subtract them, that's going to help me out, right? Now, remember, when you are subtracting, you have to be careful with your negatives and stuff like that. So I am subtracting these two. So 1 minus 2. Right? So I've got 2x minus 2x. That's just going to be 0x. What's this one going to be? Negative 5x. Oh, sorry, negative 5y minus y is... What did you get, Sam? Negative 6y, yep. And then here again, I've got negative 11. This whole thing really should be minus, so minus 7. That's negative 18. So then I've got negative 6y is equal to negative 18. And so y is equal to 3. Divide both sides by negative 6. And we can also sub it back in. Eva, which one looks easier, do you reckon? Yeah, I mean, they both look a bit complex, but the second one I'm saying, oh, there's one variable of y there. I don't have to do any multiplication, right? So I've got 2x, so sub y equals to 3 into the second one. And so I'll say 2x plus 3 equals to 7, and I can rearrange, right? So you should get y equals to 3 and x equals to 2 as your answers.